Now, boss.
Right, you've been to Shrewsbury,
Yes,
you've seen Morris Lubricants and how we make the oil.
I have.
So now we're looking at how we use the oil. So we're in the off-highway sector today,
Go on.
and we're standing in front of a lovely excavator, as you can see. And the subject today is hydraulic oils,
Go on.
and how important it is to get the right hydraulic oil for that application. Okay. So if you look at the excavator behind us, there's lots of hydraulic systems on there, okay, and they all rely on the quality and the performance of the hydraulic oil to do their job correctly.
Yeah, yeah.
So first of all, you've got the standard hydraulic system. We can see part of the boom arm here. So the way the whole machine operates from the slew gear up is obviously hydraulics. The heart of any hydraulic system is the pump. Okay, we need to look after the pump. So the pump makes sure you've got the hydraulic pressure required in order to carry out its working duties, basically.
Yeah.
On plant and construction equipment like this, you tend to get the slightly more sophisticated pumps, like the variable displacement piston pumps, which are very fine control. And obviously where you are, you're sort of handling equipment like this, and you want very fine control.
Which you do, yeah.
Which
Big
you do.
machine.
Yeah, absolutely. Big machine. Lots of safety involved, of course, as well. So you want precise control. Rotary vane pumps as well. But all of these pumps are very intricate working mechanisms. So part of the hydraulic oil's function, apart from obviously applying hydraulic pressure to do a job of work, is to look after all those components as well. So all those moving components. So you need to protect them from wear, you need to protect them from rusting and corrosion. So there's a lot going on in there, and poorly formulated hydraulic oils will not look after your pump, which tends to be the most expensive part of the whole system if you've got to replace it.
Is that right? If you had to change the pump on this, it'd be more expensive?
Variable displacement piston pumps on this kind of equipment can be quite big and very costly to replace.
Okay, right.
So wear protection is paramount, rust and corrosion protection is paramount. The other thing you don't want happening in a hydraulic system is foaming. So if you get foam, and of course you've got a mechanical system which is thrashing oil as it's going around, okay, through the pump, through the control valves, back again, back into the reservoir. If you've got foam, you've basically got bubbles, and if you've got bubbles, you've got no oil. So if you're putting foamy oil back around a system, that's not good, because
the compressibility of the oil then.
Exactly, yeah.
So no control.
Exactly, and the whole reason why a hydraulic system works is hydraulic oils are virtually incompressible.
Yeah.
So whatever pressure you put one end is coming out the other end.
Okay, yes, yes.
So if you've got any sponginess in there due to poor foam control,
that's a bad hydraulic oil.
Bad hydraulic oil. So improper operational efficiency, but also you're starting to get wear in places because air isn't going to lubricate the pump.
Yeah, I understand.
You know, okay. So foam control is really important. The other important feature of a hydraulic oil, a good quality hydraulic oil, is its ability to cope with water ingress. Okay.
Yeah.
So it can be water coming in from through the breather. Okay. We could be working in humid conditions. We could be working in very wet environment for whatever reason, and you don't want that water to kill the performance aspects of the hydraulic oil, and poor quality anti-wear chemistry and anti-corrosion chemistry can be badly affected by water contamination.
Go on.
It can basically make it not work at all. So you've just got oil going around the system. So the oil has got to be very capable and compatible with certain levels of water. So a lot of the big pump manufacturers have specific screening tests to make sure that the water does not affect the additive system and its ability to protect.
Right, is that right?
Yeah, so water's important.
So getting wetter is always, that always happens then?
It can, yeah, to different levels and different degrees.
What, in the form of condensation?
Form of condensation, but as I say, it could be humid conditions, because obviously the reservoir has to breathe.
Yeah.
And if it is breathing in humid air with a lot of water content, that can be another way of getting it in there. So any water, and we're talking microscopic amounts sometimes as well. We're not talking huge amounts, you know, but that can have an effect because all the chemistry works at the molecular level. So you don't need a lot of water to start to have an adverse effect if that chemistry isn't strong and robust enough to be able to cope with it. So that's all the kind of chemical needs that you need to, you need in place, all the kind of chemical properties. But beyond that, one of the biggest operational challenges for hydraulic oils is operating temperature range.
Yeah,
okay,
yeah.
So
go on, what's the normal range for hydraulic oil? It's not like engine oils, would it be?
No, but...
where you see, 110, 120 degrees. What would you see in hydraulic oil?
But it's more to do with operational. So if this is in the middle of an exposed construction site in the middle of winter with a wind chill factor on it,
yeah,
-20, for example, you need to be able to jump into the cab and use the hydraulic system straight away.
Yeah.
You don't want any sluggishness.
No.
And then, of course, on the other end of the spectrum, when the machine's been working hard for a long period of time, and this could be in the middle of summer, so your ambient temperatures are really high as well, you still want that hydraulic system to perform as equally as good as it was if it was just starting up from cold.
Yeah.
So you've got predictable operational capabilities from that hydraulic fluid. So you have something called high viscosity index hydraulic fluids, which are designed to give you good cold start fluidity when it's cold and you're jumping in the cab and you want to make things work, all the way up to hot operating temperatures. But you've got consistent operational performance from the hydraulic system. And bearing in mind, some of these may not be, you may be literally just changing the operator. Now, if you've got a big project on, there's a time scale, when these things get hot, they get properly hot basically. So you need a hydraulic oil which is going to cope with those high temperatures. So one of the other things you have to cope with is the thermal oxidation stability of a hydraulic oil, which is how the hydraulic oil puts up with those high temperatures without breaking down itself, okay? So you need antioxidants in there to look after the hydraulic oil itself so it doesn't become oxidized.
Yeah.
An oxidized oil is basically something that gets really thick, it starts to polymerize basically. If it becomes thick, of course, its ability to flow and cool isn't there either, so you don't want it getting thick. But as it oxidizes, it can start to form acidic byproducts as well. And acidic byproducts obviously can start to attack the metallurgy in the system. So you have to have antioxidants in there to give it good thermal oxidation stability at high temperatures. So you need to build that in. So that's part of the hydraulic system or hydraulic oil story. The other part is, as with this particular piece of equipment, is this has got a hydrostatic drive on it. Okay, so a hydrostatic drive uses hydraulic energy to drive the tracks in this particular case.
Okay, yeah, no mechanical drive from the engine. No. There's no mechanical connection from the engine to the track.
Absolutely. So you've got a mechanical hydraulic pump converting mechanical energy into fluid energy, which is then pushing another hydraulic motor at the end of that, converting it back to mechanical energy, which will then turn the tracks, essentially. Okay, so that's another part of the hydraulic oil story in this particular case, is not only for the general operation of the equipment, but you're relying on it to drive the tracks as well. And again, you want consistent performance throughout all these different operations, hot or cold, even if it's just standing there, it needs to be behaving itself in a predictable manner all the time. So hydraulic oil has lots of different things to do in this kind of equipment. And because this equipment is big, it's designed for big heavier workloads, if you like, with more load. I mean, we've seen some of the big excavators, we've been talking about those today already, where you can carry huge tonnage in the buckets, etc. That's beefy hydraulics, and you need the hydraulic oil to cope with that and be predictable across a whole range of different temperatures. Ultimately, a cheap or a poorly qualified or formulated hydraulic lubricant or fluid is going to cause damage. May not be straight away, but when you start to wear things out, then fluid, the operational efficiency starts to drop, hydrostatic drive efficiency may start to drop, things need to be replaced. So again, poor quality hydraulic fluid, we'll put this into a workshop for repair and downtime. And if it's in the workshop for repair and downtime,
not earning your money, boy, we keep saying that. We want the bloody thing out there.
We keep going around in circles with that, but it's the same story every time. So checking
go on, what sort of service intervals are we looking at then for something like this, something as big as this? And what will it hold? How many litres will this hold?
Well, some of these will hold a couple of 100 litres of hydraulic fluid.
Right, okay.
Because the other thing you want to make sure again is that the hydraulic oil gets a rest. So the reservoirs are designed so when the hydraulic oil has gone round the system, it gets back to the reservoir, it has a bit of a rest, all the foam can be broken, all the entrained air can come out again. It may lose some of the heat it's picked up during the process of going around the hydraulic system.
Yes.
And it may be baffled as well, so it slows its progress down before it goes back around again.
What sort of temperature are we looking at?
Well, most reservoir tanks run at around 50, 55 degrees
C. So it is fairly cool then, right? Compared to engine oil, right? Okay.
I mean, the working ends, you've got the compression where you've got the working rams and various other things. Then it may be higher than that, but the actual average temperature
would be about 50 degrees.
55 degrees C, and it's quite happy with that.
Yeah, yeah.
So you have to build a reservoir big enough to allow it to have enough dwell time in order
to act as a bit of a heat sink as well.
Absolutely,
yeah,
and let that go basically. And the only other place where hydraulic oils are important, well there's several, but one worth mentioning is the hydraulic brake circuits. Now this one doesn't have one because it's hydrostatic drive. But on some of the big loaders, etc., you may have a hydraulic circuit which applies the brakes. So it's different to your dot 4s and your dot 5.1s on your passenger cars. These will be mineral hydraulic fluids, mineral brake hydraulic fluids. So these are low viscosity, thin hydraulic fluids. So when you touch that brake pedal, you want that hydraulic fluid to transfer that power and that force to the brake system and apply the brakes.
Yeah, yeah, yeah.
So again,
but that is a wet brake system on a lot of those.
The wet brake system, but this is applying the actual clutch packs.
Okay, right, okay.
Yeah,
yes.
so this is a separate circuit which applies the clutch packs in the oil immersed brake system.
Okay.
And a bit like in a car or anything else, you don't want vapor lock, you don't want spongy brakes.
You want it to stop.
You want it to stop.
Yeah.
So yeah, the integrity of the fluids used in those hydraulic brake circuits is also very important. So that's just another example of a more tailored requirement for hydraulic fluids in this particular sector.
Interesting, interesting. Okay. Complicated stuff, mate.
Oh yeah, it never gets any easier. Any piece of plant equipment where you've got the potential to swivel the cab, and obviously in this case the rams on the arm with the bucket on the end of this particular case, then the slew gear enables you to do that. So the slew gear is where everything revolves essentially. Now the trick part about the slew gear is the swivel motor or the swivel gear, which is inside the middle of that. Mm-hmm. Now that connects the hydraulic circuit above the chassis to the hydrostatic drive below the chassis without lots of hoses getting tangled up. Because you can imagine if they're all connected by hoses, as this turns, it's
going to get messy.
You're going to get messy.
Yeah, yeah.
So there's a very trick, it's called a swivel motor or slew motor, sat in the middle of that, which is a barrel with channels machined into it, with seals between the different channels, and it enables the top and the bottom to turn without breaking the hydraulic feed from the top to the bottom.
Right.
It's trick, okay. But that motor not only allows the transfer of hydraulic power and fluid from the top to the bottom to drive the tracks in this particular case, it also drives a pinion gear around an internal ring gear. Okay, so you
to
can
be able
see,
to turn the cab.
Absolutely.
Right.
So there's a hydraulic pump in there which is turning a pinion gear around an internal ring gear. So when you want to turn the cab, that pinion gear is then travelling around that external, that internal slew gear they call it. Now that is an application for gear oils. Okay, so although we've got a hydraulic feed going through the middle of it, doing lots of lovely things, the actual slew gears themselves will be lubricated with something like an EPA T90 gear oil.
Right. Oh, so that's an independent. That's not a hydraulic oil.
No, that's completely independent. So that is actually a gearing system which requires a gear oil to lubricate.
A standalone lubrication system.
Absolutely.
Okay. Interesting.
So yeah, so hydraulic system running through it, but the actual slew gear itself and the pinion gear that runs around that internal ring gear is an EP gear oil.
Interesting.
Yeah. So for any piece of equipment, it's all if you're unsure, it's to get sort of technical advice on what is the service interval for that type of lubricant in that machine. Okay, so that will be detailed somewhere, and obviously on the basis of that, the OEM will have a specification requirement, and on the basis of that, then obviously you can pick the correct lubricant or hydraulic fluid in order to achieve those operational needs. So it's all again about ticking the right boxes, making sure the performance there, making sure the quality's there, and then that will get you the maximum lifetime out of the components of these particular types of systems.
Fair play. Yeah. Fair play.
The other thing to bear in mind as well is mixing hydraulic fluids. It's like any other fluid, whether it's in this market or this sector or any other sector, is making sure if you're mixing fluids from different brands, the specifications match up.
Yeah, bit of compatibility.
Yeah, because if you've got a high performance hydraulic fluid in this machine and you top it up with a lower performance hydraulic fluid, the machine's full of lower performance hydraulic fluid.
Yeah.
So and some of the chemistry may not be compatible with each other either. So I've heard of examples in the past where suddenly you get lots of foaming issues. So always be sure that if you're going to be mixing different types of hydraulic fluid, they meet the same specification.
Okay. Yeah.
And if you need any guidance on that, obviously you can phone our technical team at Morris Lubricants, and we can talk through it with you and give you some guidance as to what you can and can't do.
There's a load of folk there that know what they're talking about.
Yeah, absolutely. So
I know,
somebody on the end of the phone can give you a bit of a helping hand.
Yeah.
There you go. So yeah, so we're on hand to help with that as well.
Sound. Brilliant job.
Cheers, Guy.
Yeah, sound.
Excellent. Thank you. So if you want to see any more content like this or videos with Guy, then visit the Morris Lubricants website or visit our YouTube channel.